Alright, before we jump into today's stuff, we're going to do a little warm-up. This is just a solve. So if you want to pause the video here, just hit pause, write down the question and solve it. This is one of those questions that freezes people on exams and tests, so it's a good one to look at. So just hit pause and try it. Alright, welcome back. So let's have a look. I'm trying some other technology today, so my writing might be a little bit off. So bear with me. So we're going to look at this expression, and right away it's kind of scary looking because there's things all over, there's x's in all places. So what we want to do is we want to make this look like something we've seen before. So I'm going to multiply that in. Change to a smaller ink here. X cubed plus 3x squared, and then I really don't like my x's on both sides, so I'm going to add 2x to both sides, and I'm going to achieve something that makes solving way easier. I get a 0 on one side. That is a desired effect when solving polynomial expressions. So then I'm going to look at this and say, well, it's a cubic. I could do factor theorem, remainder theorem, and long division, but that's a little bit time consuming. If I look really closely, I'll notice there's an x in each one of these, so I'm actually going to factor first. So the first thing you should always look for is a common factor. Is there a way to reduce the powers to something smaller and get into the more efficient skills like decomposition and difference of squares, those types of things. So now once the x is out, it stays out front, and then if I look inside the bracket, it's actually a simple trinomial. I've got a 1 in front of the x squared, and yeah, the two numbers would be 2 and 1. So x plus 2, x plus 1, and it's all equal to 0. And now I have the condition I'm looking for. I have three things multiplied together to equal 0. So that means either this bracket is 0 or this x is 0. This bracket might be 0, which means x would be negative 2, or this bracket is 0, in which case x has to be negative 1. There's my three x-intercepts. And again, you just don't panic. Make it look like something you know. Get a 0 on one side. Look for factoring. Once you kind of do enough of them, it starts to get really easy. So let's take a look at this one. All right, it's a quartic, fourth degree. We have a 0 on one side, so that's kind of nice. So we could do this with factor theorem and remainder theorem. We could put a 3, 9, 27, 81. 3 would work. So we could do some long division. We could rip this down to be a cubic and then rip it down to be a squared. And there's a lot of work there. What we might also see is, can this be written as something squared minus something squared? And what I'm looking for is a difference of squares. So if you look at this, if I wrote this as something squared minus something squared, that's the shell of doing a difference of squares. Well, I can put an x squared in here, and I can put a 9 in here. And that would get me a difference of squares. So I would have x squared minus 9 and x squared plus 9. So that quickly moved me from a quartic. It's still a quartic, but now I have two binomial brackets in there that are just squared. So that's already nicer. And then if I look over on this one on the left here, right here, I might see that this is a difference of squares again. So now I can go x minus 3, x plus 3, and now I have to be really careful on this one. A lot of people will be tempted to do the exact same strategy, but difference of squares is subtraction. This is a sum of squares. We don't have a solution for that. So it stays the way it is. And now if you try and solve this, you solve x minus 3 set to 0, so that's just going to be x equals 3. This is going to be x equals negative 3. And then you can try this. And this is always good to try a couple times until you're absolutely comfortable with it. And then you'll start to see the pattern. X squared plus 9 equals 0. Well, let's just do this algebraically. We're going to subtract 9 from both sides. And then I'm going to take the square root of both sides. And that's where things are going to go wonky. Because I can't take the square root of a negative 9 and get a real number. I can only get an imaginary number. So this problem ends right there. So if I was looking at a graph, and I'm just going to make some wild guesses here. So I have x-intercepts at 3 and negative 3. So I have to draw some sort of W shape like this. So it could look something like this. Go down, up, and then it might do something like that. And because this term right here is in root -9, that means this turning point, this area right here, doesn't actually contact the x-intercepts, so there aren't any. Now that turning point could be on the other side, it could be below, it could be a whole bunch of different locations. But the key piece is that there are only 2 x-intercepts. Okay, so let's jump into what we're trying to work on today, and that's solving polynomial inequalities. So there's that solving piece, but now we're also including inequalities. And we're going to stick with this table format. It's very popular. It's also called an interval format, whatever you need to do. So you can have a polynomial inequality, but it becomes more difficult to determine a solution because now there's a range of answers. So this right here is the mathematical way of saying negative. So when is this quadratic negative? That's what it's asking you. So we have a couple things we could do. We need to first find out our zeros, our x-intercepts. So let's go down and find our x-intercepts. So if we have y equals x squared minus x minus 2, we could go y equals x minus 2 x plus 1. We set this to 0 to find our x-intercepts, and we come up with our 2 answers. So we have 2 comma 0 and -1 comma 0. So my apologies, I'm running out of space here, so I just left out a little bit of the arrow work. So now if I come back up to my table, I'm just going to put a -1 here and a 2 here. These are going to be my dividing lines. If I plot them on my graph, I might use a slightly larger scale. I'll use 2 dots. Equals 1 unit, so I can barely see that. I guess I could have made that larger. Doesn't really matter. It's also a happy curve. It's got a positive coefficient out front. So we're going to draw something like that. And again, it doesn't really matter because all I'm looking for is the negative location. And you can see right here, the negative location is everything inside these 2 numbers. So the inside terms. So we would expect that when you do a little table that these guys here come out negative. So we have our picture, we sort of have an answer, but let's just go through the process just to make sure we actually get the process dialed in. So my first interval is going to be x less than -1. My next interval is -1. I didn't leave myself very much room here, did I? Less than x going to 2, and then the last interval is x greater than 2. So if we look at our binomials that are multiplied here, so if we choose a value for x that is less than -1, let's say -5. So if I put a -5 in here, both brackets, the first bracket is negative, the second bracket is negative. A negative times a negative gives me a positive, which shouldn't be a big surprise. These are all positive values that are plotting on the graph. If we choose a value between -1 and 2, let's choose a 0. So if I plot that in here and I change this to a 0 now I have a negative times a positive, so a negative times a positive, and big surprise, we get a negative value there, which is this value right in here. And then lastly, let's choose 5. So we put a 5 in here, and we end up with positive times a positive is a positive. And that supports our graph, which we already knew the answer to. So the table format works. It's a great tool to have moving forward. Knowing what shapes the graph looks like are also really important because these 2 things have to talk to each other and make sense. So let's try something a little bit bigger. What if you had a cubic? So it becomes a little bit more difficult. Now there's a whole bunch of work to get from here to here. This is your factor theorem, your long division. So that skill's not going away. You have to be able to take this cubic in standard form and rip it down to factored form. So just to save some time, I've already written it out. So your zeros are 1, 3/2, and -4. So if we were to plot those, I'm going to blow this up a little bit. It's hard to see. So let's go -4. It's about there. 1 and 1.5 is going to be really hard to draw. So if we just made a quick graph, it's also a HAP, or positive leading coefficient. So we have that, what we call happy disco. So this guy is going to go up, down, and around like this. So if you were looking for this interval here, on what intervals is this function greater than 0? Well, that's a fancy way of saying positive. So if I asked you to grab a highlighter and say highlight where this graph is positive, well, you'd say it's all of this up to that point, and then it goes below the axes, and then everything past. So if you wanted to tell me where is it positive, let's get back on a pen here, you'd say, well, from this point on, when x is greater than, what is it, 3 over 2 over 3 over 2, 1.5. So when x is greater than that value, this is all positive. And then in between here, you would say this is also positive, and that is the interval x is less than 1 but greater than -4. So those would be your two answers to this question. And if you can draw a nice graph and put the x-intercepts in, you can draw this from the graph. But I'm going to warn you, we want to be able to do this table because there will be graphs that we can't draw very easily, and the table will save your bacon. So if we do the same thing here, and I've set this up in a table already, all we're going to look at is, let's choose some numbers and put it in these brackets. So x is less than -4, let's say -5. So when you put that in each bracket, you have a negative in the first bracket, a negative in the second, and a negative in the third, and that gives you a total. When you multiply three negatives together, you get a negative. Oops, I put that in the wrong spot. Let's move those over. Drop that there. Drop that there. Okay, and then let's jump back in. Lost my pen. We'll do the next one in green just for fun. So let's choose 0. So now you put a 0 in here. This goes to 0. This is 0. So now you have a negative times a negative times a positive, and the result is a positive. Okay, and then let's go to red, between 1 and 1.5. Okay, well, let's just do 1.2. It doesn't really matter what we choose as long as it's inside that interval. So 1.2 minus 1 is going to be positive. 1.2 times 2 is 2.4 minus 3, so the next bracket is negative. And then the last bracket is positive, so we're back to a negative again. And then lastly, we'll finish with a black marker here. Let's just choose 10 because it's easy. So that'll be positive, 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 and that plot's positive. So if we were to graph this, and let's choose blue, here's an x-intercept here, here's another one, here's another one. Our graph has to be below, that's what the negative means right there, below, and then this has to be up, and then below, and then up. And that's exactly what the cubic looks like. Granted, these two pieces here are a little tighter together, but if you look at the picture, that's the same thing we drew here. So this table is really handy, especially if you're going to do calculus. You'll see it with the first derivative test and a couple other locations. So don't bail on the graph just because, on the table just because you know what the graphs look like. Our next unit, it'll also become very important. So have a look. Try this one. You want to pause the video and just give it a whirl on your own. Set up the table, put the numbers in, and then come up with solutions. Okay, so hopefully you've had a chance to pause it. So I'm just going to draw this really fast. 1, 2, 3, 4. So if I write this is x equals -5, x equals 3, -1, and 4. And now this is one thing that's really important. You have to put these in the order from smallest to largest. And I know that seems obvious, but sometimes people don't do that. So of all these numbers, -5 is actually the smallest. Then -1, then 3, then 4. Just as if they were on a number line. This bracket would be x is less than -5. This bracket is going to be x has to be greater than -5 but less than -1. And you do start to get a little bit of a trend on how to write this stuff a little quicker once you've done it once or twice. And then lastly, x is greater than 4. So there's some trends. You can see the arrow, The inequalities point outward, so the left one, if you think of an arrow, it's pointing to the left. On the right, it's pointing to the right. Like just little details that help spot mistakes. So this -2 out front, this is actually important. This -2 here, it provides a negative to each one of these. So even though it doesn't get an x value, it's a negative multiplier. And so it's really important for making sure that our graph ends up being an upside down W or an M-like shape. So you can't miss that negative. That's why this example is here. So now let's choose 10. So we'll say 10, or sorry, -10. So we put a -10 in here. We've got a negative times a negative times a negative times a negative, and the result is a positive. And then let's choose between, let's go -2. So now we already have our negative up front, so now we have another negative, another negative, a negative, and a positive. So that ends up being double check my calculator. I got one too many terms here, do I? 1, 2, 3, 4, 5 total. Well, I'm missing one on the first one, that's why. So this should be positive. Let's go back to that first one. What did I miss? So there's a negative first, 1 bracket, 2 bracket, 3 bracket. I missed the 4th bracket. That's what I missed. So this is not positive. Get back out of there, you. It happens to all of us. So there's a negative. There we are. And then let's choose 0 for this interval. So the negative of the 2 is up front, then a negative, a positive, a negative, and a positive. 1, 2, 3, 4, 5. Okay, got them all this time. And it's negative. And then let's choose 3.5. And you can start to make predictions. Like you already know what this is going to look like, but we're just practicing so we have the skill at this point in time. So this will be a negative, and then a positive, positive, and a positive. So you put all that together and you get a positive. And then lastly, let's choose 10 down here. So we'll have the negative at the start, positive, 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 and we end up with a negative going down here. So if we draw our graph really quickly and we mark out those x-intercepts, and let's draw it in red. So this says negative, so I should be below, then positive above, negative below, positive above, negative down, and there's my M shape, which I doodled at the top here with a negative leading coefficient, and everything checks out. Alright, there's a few questions to try. Hope that helped, and thanks.